Good day once again, ladies and gentlemen. And we are back looking at analytical geometry from the November 2022 exam. So if you haven't subscribed, please just make sure you're part of the family. And of course, you can join in as a member in this channel, right? Where you can get valuable perks like NBT as well as our just regular meetings where we discuss maths and science on Sundays. All right, so let's have a look at it. So, question 4 on analytical geometry, obviously having to do with circles. So, they say in the diagram we've got M, which is 3 and -5, which is the center of a circle having a PN as its diameter, right? KL is a tangent to the circle at N, which is 7 and -2. Okay, so the first thing that they ask us to do is to calculate the coordinates of P. Now, of course, they have told us that that's a diameter, so it must mean that, of course, the value M, or in this case, the coordinates of M, would be the midpoint. So I can find the other side by applying the midpoint formula, right? So I can say, so for 4.1, I know that the x value at M, right, let me just write it nicely. X value at M would be x value at P plus the x value at N, right, over 2. But the same thing for y values, right? So y value at M would be y at P plus the y at N over 2. All we need to do is just substitute here. So we know that the x value at M is 3. Okay, at P, that's the one that we're looking for. The one at N is 7. And divide that by 2. All right, so we just cross multiply there. So 2 times 6 and 2 times 3 is 6. Okay, and xp plus 7. If I take that to the other side, xp becomes -1. Okay, right, so let's do the same for the y values. Okay, I know that the y value is -5. Okay, and at P, that's the one that we want. Okay, and at N, that value is -2. Okay, and divide that by 2. All right, let's find that value quickly. So we know we are going to cross multiply again. -5 times 2, that's -10. And this is yp -2. And if we take this to the other side, yp then becomes -10 plus 2, which is going to give us -8. All right, and I did say to you, please always make it a point that you always verify. Okay, so that's -1 and -8, right? So we need to check, does the point P lie where both x and y are negative? And it really does look like that. So I'm going to actually write those points there. There's those coordinates. That's -1 and -8, right? Okay. Now, the next question, they say determine the equation of the circle in the form xa blah 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 and is equal to r squared. Well, we already have the center, so we know what a and b are, right? All we need to do is calculate the value of r, and all we're going to do is, just determine the distance there. Okay, that would be our radius. Okay, so we're going to take the distance mn, right? So I'm just going to take this down there. Right, so we're finding the value of mn. And in fact, because we're going for r squared, why don't we just calculate mn squared, right? Which would be r squared. So that would be xm minus xn all squared plus ym minus yn squared, right? And remember, in this case, the coordinates of m and n respectively. Okay, I didn't write them out. Actually, I should have So this is 4.1, sorry, 4.2 in this case, and in particular 4.2.1. I really apologize for not writing legibly there. All right, so the coordinates of M, remember we said that's 3 and negative 5. Okay, and so that's 3 and negative 5, that's M. And for N, we said that's 7 and negative 2. Okay, so that's 7 and negative 2. Okay, I'm just checking if I've got that correctly. Okay, right, now we can find M and N, right? So this is going to be negative 5 minus a negative 2. Please keep that in mind. Let me make that square brackets. Okay, plus y value at M, right? So, oh no, I swapped the values around, right? So, M, that's 3 and minus 7. Okay, as well, now we're looking for M, ym, that's minus 5 and minus a negative 2. Okay, right. Okay, I think we okay now. So that's 3 minus 7. In this case, that would give us negative 4, right? But negative 4 squared gives us 16. And we've got negative 5 plus 2, right? Which will give us minus 3. In this case, 3 squared would give us 9. Okay, so we know that 16 plus 9, which should give us 25. Okay, so we know that r squared is 25. So we can write down, we know what m is, so that's going to be x minus 3 squared plus, that's y minus, y plus 5 squared. Remember, it changes sign when it gets into those brackets, and this is equal to 25, which is the radius. Okay, right, but remember we must express it as the radius squared. Right, so now the next question, they say to, we must go for this one. They say determine the equation of KL in the form y is equal to mx plus c. Now, remember our theorem, the 10 radius theorem, right? We know that KL would therefore be at 90 degrees, right? So KL would be at 90 degrees to MN. Remember, line that is drawn from the center, okay, will be perpendicular to the tangent at the point of tangency. So we know that though they form a 90 degree angle there. So that means that the gradient, okay, if I can find the gradient of the line MN, right, we can therefore find the gradient of KL, right, which in this case we can therefore find out, or in this case determine the gradient of KL that way. Right, so let's do that. Okay, let's take this down there. So let's find, that's 4.2.1, right? 0.2 rather. Okay, so that's 4.2.1. So let's find the gradient of MN, right? And in this case, we've got the points MN. So that's going to be ym minus yn over xm minus xn. All right, so let's do that. So that's going to be negative 5 minus a negative 2 divided by xm is 3, and we subtract that 7 there. Right, so we get there, that's going to be minus 5 plus 2 will give us negative 3, okay, and 3 minus 7 will give us negative 4. So I get a gradient of 3 over 4, right? I hope that's correct. Okay, so now, therefore, it means that the gradient of the line KL should therefore be equal to the inverse of that. Okay, remember with a changed sign, right? So it means that the gradient of KL would therefore be negative 4 over 3. Remember that the two gradients, when you multiply them with each other, should give us a value of negative 1, right? So all you simply do to get the gradient of the other, you just flip the one around, or you just invert it and you change the sign. Right, so now we know the equation of KL would be y is equal to negative 4 over 3 plus c, right? And how am I going to get my c value? I am going to make sure that I substitute the point that y passes through, which is point n, which is 7 and negative 2. Okay, so I'm going to substitute the 0.7 and negative 2, right? So when y is negative 2, okay, let's write that nicely. So when y is negative 2, okay, x is, sorry, I forgot to write x there. Over 3, x is 7, and we're looking for our c value, right? Okay, so let's find that out. So that's going to be negative 2. When I take this to the other side, that's going to be plus, right? So that would be plus 4 over 3. Okay, multiplied by 7. Okay, so I get 22 over 3. So our c value is 22 over 3, right? So, okay, let me just make some space there, ladies and gents. Right, so that's going to be 2 over 3, right? So in this case, I've got y is equal to minus 4 over 3x plus 22 over 3. All right, so that is how the cookie crumbles. Okay, so now let's go on to the next one. They say, for which values of k will y is equal to minus 4 over 3 plus k be a secant to the circle? Okay, all right. Now remember, what is a secant, ladies and gents? Well, a secant is a line that cuts through the circle more than once. Okay, of course, it would cut the circle twice. All right. Now, so you can think of a secant as a line that is not a tangent, right? But that does touch the circle. So it would actually pass through, the circle. So for instance, if I drew a line like that, that would be a secant, right? So in this case, they want to know the values of k. Now, please, I want you to note that they are using the same gradient as the as that of KL. So they want to know what would be the upper and the lower boundaries, so that it doesn't become a tangent. Okay, but remember, where would that line be a tangent? Okay, I want you to really think about it. It would be a tangent at n, right? But if I shift it, it would also be a tangent at this point here, right? So what I'm going to do is I'm going to substitute that point. Okay, we already know what the y value here is. We said y is equal to minus 4 over 3 x plus, I think it was 22 over 3, if I remember correctly, right? So let me find out what would be the y-intercept of a line that would pass through this point P here, right, with the same gradient. So that's the rationale, right? So I am going to say, right, so if I take the equation y is negative 4 over 3 x, right, plus k, and I substitute for the point P, right? We said point P is, so we said that's negative 1 and negative 8, right? So the point negative 1 and negative 8, right? So I'm going to say, well, when y is negative 8, negative 4 over 3, negative 1 plus k, right? Let's find out what the value of k is there. So that would be negative 8. So that would be minus 8. When I take that to the other side, so negative and negative would give me positive, but when I take it to the other side, it still becomes negative, right? So so I've got minus 8 minus 4 over 3. Okay, and that gives me k is minus 28, over 3. Now, they wanted to know for which values of k. So k must be between this value here as well as the value for the y-intercept rather of our tangent, the previous tangent, right? And they said it must be a secant, so it means it must not be a tangent. So it means we're not going to include the values where this guy becomes a tangent. So k would be an element of, we always start with the smaller value, so must be an element of negative 28 over 3, right? As well as the upper one is 22 over 3, right? Excluded there. Or you can simply write it as k is less than 22 over 3, right? But it must be greater than negative 28 over 3. Right, I hope that makes sense, ladies and gents. Right, as we move on to the next part of this question. Okay, let me just try to zoom in a little bit. Right, now they say to us, we've got point A, which is T and T, right? And B are not shown in the diagram. Okay, so it's a random point. They say from point A, another tangent is drawn, okay, to touch the circle with center M at B, right? Show that the length of the tangent AB is given by that expression. Okay, so let me do this, ladies and gents. Let's, just for the sake of seeing what we're trying to do here. So they're telling us we've got another point that is outside the circle, which is point A, right? And we've got another point which is point B, right? Now they say point A, from point A, right, another tangent is drawn which touches the circle at B. So suppose we draw a line. Okay, let's say here it is. Okay, so there's our line there. Right, so meaning that we are going to call this, point B, right? And point A is that point outside of the circle. I don't know why I made it that long. Okay, right, now remember we still have point M. It's still the same circle, right, with the same radius and so on. But what we're going to do now is let's try to show, they said, so this is point A, which is T and T, okay? And they say that we want to show that the length of AB, okay, so we're looking for the length of AB, right? So remember we already know what this length is, okay? That's our radius, and our radius will be 5, but remember we said a radius squared is 25, right? And of course, if we take this there, now remember the tan radius theorem gives us a 90 degree there. So we know that value is 90 degrees. So, right. So we want an expression for AB, ladies and gents. I want you to keep that in mind. Oh, and by the way, we know that point M, so point M was, please remind me there, 3 and negative 5. Okay, so this point here is 3 and negative 5, right? So now to get the value of AB, remember I don't have the coordinates of B. I'm going to use Pythagoras there because it's a 90 degree triangle, right? So I'm going to say, well, look, AB squared, right, would be equal to, in fact, the square of the hypotenuse, am squared would be equal to, rather am squared, yes, would be equal to mb squared plus ab squared. But because I'm looking for ab squared, I'm going to say this is going to be am squared, the hypotenuse, minus mb squared, which is that distance there. Right, so let's do that quickly. Now, let's take am. Okay, am would be, please, I want you to note there, I've got t, so I'm taking the x value minus the x value at m, so that would be t minus 3, right, squared, okay, plus, okay, let me just put this in a bigger bracket, so that's t minus 3 squared plus t minus a negative 5, so that would be t plus 5, so that's t plus 5 squared as well, right? Remember, you're dealing with the distance formula in this case, so am, okay, is actually squared in that case, right? So what I'm simply going to do, no man, actually I am making, yeah, no, sorry, that's am squared. So that would have been, remember, square root of, if I was just looking for am, so I don't need to actually square that there. All right, so that's am squared. So that's minus, I'm still going to put it in brackets though, so that we can work through it separately, minus the distance mb, that's going to be 5 squared, right? So let's try and work that out. So we can take, that would give us t squared minus 6t plus 9. Now please remember, ladies and gents, all the time when you are squaring brackets, it's going to be this one squared, this multiplied by that, multiplied by 2, which is minus 6t, right? And then obviously it's the outer one squared as well. Okay, this is plus, this is going to be t squared plus 10t, okay, plus 25. All right, that's minus 25. Okay, so let's work out what is in there and try to get, see whether it does give us, you know, what they actually had in mind, right? The length of AB. Remember, we're dealing with AB squared for now. Okay, we'll get to AB, the square root, right? So this is going to give us 2t squared inside the bracket, right? And then we've got minus 6t plus 10t. That would give us plus 4t, right? All right, and then I've got, in this case, 9 plus 25, that would give us 34. Okay, but we've got a minus 25 there, so that would give us a 9. Okay, right, if we add everything up with the minus 25. Okay, so does that look 2t squared plus 4t plus 9? Definitely it does, but because we're looking for AB, right, we're going to put this in under square root. Okay, right, I hope that makes sense, ladies and gents. Right, and then the next question, they say determine the minimum length of AB, right? Now I want you to please note that this actually forms a quadratic equation, that is inside there, right? Now remember, what do we do to minimize? Okay, we always take the gradient and make it equal to 0, right? Or in this case, if you want to, you can use, because it's a parabola, remember, you can just, where is the value minimum or maximum? It would be at the turning point, right? So I can find the value, the x value or the t value at the turning point. Okay, so that is 4.4.2. Okay, so I can find the t value at the turning point. So I can say t, right, that's minus b over 2a, right? So that would be minus b. Our b value is 4 divided by 2 times our a value is 2 there, and in this case I get -1, right? So it means that the turning point of that quadratic will be at -1, right? So all I'm simply going to do is say, all right, let's find out what would be the minimum value of AB, right? So I'm going to say that for AB, going to substitute the point -1 into that. Okay, so that's 2 times -1 squared plus 4 times -1 plus 9. Okay, let's find that value. 2 times -1 squared, that would give us 2 minus 4, right? So in this case we've got so positive 2 minus 4, that would give us -2, and then plus 9, that would give us 7, right? So it means that the minimum value of AB would be equal to the square root of 7. Okay, another way that you could have done this, ladies and gents, was to take the derivative, right, of this function here, right? Remember, when you take the derivative, that would, and you make it equal to 0, right, to find that t value, right? So you could have said, let's just call that g, right? G of t. So g of t would be 2t squared plus 4t plus 9, right? So what we would have done is take g dash of t, okay, and in this case that would give us 4t plus 4, which is equal to 0, and again t would be equal to -1, and you do the exact same thing there, right? Another way would have been to complete the square. I'm not sure if you really want to go there, but completing the square will help you get your values for of course your values for your turning point, and you would get your turning point in that way. Okay, right, but I'm going to leave it here, and of course we will see each other again. We're still going to do some geometry and some Euclidean Euclidean geometry as well as trigonometry. I'll see you guys next time. Sharp sharp.